the previous case 1, you had a straight line parallel to time axis. Here you have a straight line inclined to x-axis. Displacement by time. What is displacement? Change in position with respect to time. So we have velocity along y-axis and time along x-axis. Change in velocity is your acceleration and change in position is your displacement, and displacement by time is nothing but your velocity. Hello everyone, I am Nishma Nanjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to Session 3 on Chapter 3, Motion in a Straight Line. So far, in these sessions, that is Session 1 and Session 2, we have come across more interesting topics on motion in a straight line. So in this session, we shall study the graphical representation of motion. So what is this graphical representation of motion means? In this session, under the graphical representation of motion, we shall study the first one, that is the position time graph. Then we shall move on to the velocity time graph. So what do you mean by this position time graph? What is the significance, purpose of studying this position time graph? We shall try to understand that in today's session. So it is a graph obtained by plotting. It is a graph obtained by plotting time along x-axis and position along y-axis. So what do you mean by position time graph? It is the graph obtained by plotting time along x-axis and position along y-axis. So this is a graph where the object or the body is at origin 0. So along the y-axis you have position that is given as x, and along your x-axis you have time. So position time graph is also represented as xt graph. So position is given along the y-axis and time is recorded along x-axis. So the graph which represents the time and position is known as position time graph. Under this there are 4 cases. We shall try to understand what are those 4 cases. So the first case, under position time graph, we are studying the first case. So what is the first case? That tells us for an object at rest. For an object at rest, the position time graph is a straight line. Is a straight line parallel to time axis, that is x-axis. So your position is along y-axis and your time is given along x-axis. So you have a body at point O, at origin O. So now what happens is you have 2 axes. Say this is your y-axis, this is your x-axis. So time is along x-axis and position is plotted along y-axis. And the body is initially at origin, that is it is at rest. Say you have position say 2 meter and time is 1 second, 2 second, 3 second and so on. For 1 second of time, the object will move 2 meter along y-axis. So it moves along 2 meter. And after some time, the body again for 2 seconds, so increase in time, it moves 2 meter. Again for 3 seconds, increase in time, for 1 more second, it will move 2 meter. So if you join the points, you'll get a straight line. This straight line is parallel to x-axis, that is time axis. So for an object at rest, what do you mean by body at rest? That is no change in position of body with respect to time. There is no change in position. So initially it is at rest at origin, and as time increase you can see the position is 2 meter itself. There is no movement on the body as time increasing. So we get a straight line. This straight line is parallel to time axis. That is what is explained in case 1. Then what is case 2? Look at case 2 here. What does a case 2 explains us? Similarly, like case 1, it was at rest. Now what happens in case 2 is, you have an object or a body moving with a uniform velocity. Moving with a uniform velocity, the position time graph is straight line inclined to x-axis. Again, you have a straight line. In the previous case 1, you had a straight line parallel to time axis. Here you have a straight line inclined to x-axis. It is inclined to x-axis, that is time axis. So what is this object moving with uniform velocity? Uniform means same. It is moving with same or constant velocity. There is no increase or decrease in velocity. It is moving with a uniform velocity. No decrease or no rise in velocity. So uniform velocity will give you a straight line which is inclined to x-axis where time is represented. That is your case 2. Case 1, the object was at rest. We get a straight line parallel to x-axis. In case 2, the object is moving. It is not in rest. Moving means it is under the action of motion. What is motion? I have explained in the previous session. Motion is the change of position of an object with respect to time. You can see if you plot this as 2 meter, this is 3 meter, this is 4 meter, and you have time 1 second, 2 second, 3 second, you have 4 second. For 1 second of time, the body was at rest and now it's moving with a uniform velocity. There is no increase or decrease in velocity. It has moved to this point, and with again increase in time. For 1 plus 1, for the 2 second it has moved 3 meter. Again for 3 second it has moved 4 meter. If you join the line, you are getting a straight line, not parallel but inclined to x-axis. That is your case 2. You saw what happens with uniform velocity. Now what happens if there is increase or decrease in velocity to this position time graph? That will be explained in case 3. For an object moving with increasing, we studied uniform velocity. Now it is increasing velocity, that is positive acceleration. It is showing positive acceleration. So that means, what do you mean by positive acceleration here? An object is moving with increasing velocity. It is increasing, so it is a positive acceleration. So what is acceleration? It is nothing but change in velocity by time. Change in velocity by time gives you acceleration. So increase acceleration is change in velocity by time. By time taken gives you acceleration. So change in velocity. Here the object is moving with increasing velocity. Increasing velocity gives you positive acceleration. That is why you don't have a straight line. Why not straight line? Because it is not uniform velocity. There is increasing in velocity. So it traces a curve. It gives you a curve instead of a straight line, which represents increasing velocity. Increasing velocity is equal to positive acceleration. Now what happens if there is a decrease in velocity? That is explained by case 4. So case 4 explains the decrease in velocity. Look at here. Let us read the definition and try to understand what is this decreasing velocity trying to explain us. For an object moving with decreasing velocity, negative acceleration, that represent negative acceleration. I have said in the previous session, in the session 2, that if you have decreasing velocity, if you have negative acceleration, we call it as deceleration or retardation. We have studied in the previous session. So please watch the previous session to understand what is deceleration or retardation. So if an object is moving, now it is not in rest as in case 1. In case 4, the object is moving with some speed with decreasing velocity. They are specifying it is decreasing. It is decreasing velocity. So there will be negative acceleration. So change in velocity by time. The change in velocity is decreasing. So it is decreasing. So we get negative acceleration. So the curve just opposite to positive acceleration. So you have, it is decreasing from y-axis. The direction is this way. You have the cross form of this curve. So it is ulta. You have got position on the y-axis, time on the x-axis. So this is a position time graph, but there is a object is moving. It is moving as time increasing, but at particular point of time, even though there is increase in time, the position, you can see velocity is decreasing. So it is negative acceleration. So in position time graph, what did we study? So we plot time along the x-axis and position along the y-axis. That gives us position time graph. And next we studied 4 cases under position time graph. What is the first case? Which tells us if the body is rest, then what happens? If a body is at rest, it gives us a straight line which is parallel to time axis. In case of it is moving with uniform velocity, in case 2, object is moving or body is moving with uniform velocity. That means again we get a straight line but not parallel, inclined to x-axis or time axis. Next we saw case 3. Uniform velocity is the same velocity. What if there is increase or decrease in the velocity? That is explained by case 3 and case 4. In case 3, we saw object is moving with increasing velocity. If it is increasing, it represents positive acceleration, because acceleration is change in velocity by time. So next we saw case 4, where object is moving. Even it is moving but with decreasing. At some point here it is started decreasing. So decreasing velocity means we have negative acceleration. That's why I've given arrow which represents it is decreasing. So next we have velocity time graph. So far we studied position time graph. Now let us study what is this velocity time graph. Now we studied position time graph. What is the significance and purpose of studying this position time graph? And why should we study this velocity time graph? The slope of position time graph at any instant of time gives us the velocity of object at that instant. So the slope of the position time graph gives us the velocity, whereas velocity time graph, the slope of velocity time graph gives us the acceleration at that instant of time. So position time graph gives us velocity time graph gives us acceleration. So the area under the curve gives us the displacement at that instant of time. The slope under the area gives us the displacement. So we'll come to that. Before, try to understand velocity time graph first. So velocity time graph is given as VT, velocity time graph. So what is this velocity time graph? You have a x-axis, we have a y-axis. We are studying the motion in one-dimensional. Previous session we studied the types of motion, where motion in 1D. 1D means one-dimensional. Any one of the coordinate specify the motion of the object. So you have y-axis and you have x-axis here. Along x-axis again we have time t. Along y-axis instead of position we have velocity represented by v. What is velocity? Displacement by time. What is displacement? Change in position with respect to time. So we have velocity along y-axis and time along x-axis. So this is the object which is at origin O. So this is our VT graph. Velocity along y-axis, time along x-axis. Even under velocity time graph, we have cases, 5 to 6 cases. Let us look at what are those. So next, case 1. Now we are studying velocity time graph. Under that, case 1. So what does case 1 tell us? The velocity graph for a body traveling with a uniform velocity. A VT graph for a body or for an object which is traveling with uniform, with the constant velocity, Z has zero acceleration and is a straight line parallel to time axis. Similar to case 1 in position time graph. In case 1, the object was at rest, but even we got a straight line parallel to time axis. Similarly, in case 1, for velocity time graph, when VT graph for a body which is traveling, it was at rest at position O, that is at origin. Now it is traveling with a uniform velocity. So we get a straight line. When it be moving with a constant velocity, we get a straight line. This straight line is parallel to the time axis. This is the case of uniform velocity. Next, what if the body is starting from rest and moving with uniform positive acceleration? What do you mean by this statement? So the case 2 in velocity time graph is explaining us that if a body is starting from rest, if it is starting from rest, it is at O, that is origin, and moving with uniform positive acceleration. Uniform positive acceleration. What do you mean by uniform? When it is uniform, we get a straight line. There is no decrease in acceleration or increase in acceleration. It is uniform. It is uniform throughout. Body is traveling throughout its travel, it is uniform. The acceleration is uniform. A body is starting from rest, it is moving uniform acceleration. So that is case 2. What was case 1? The object was moving with constant, with uniform velocity. It was moving with uniform velocity. We got a straight line that is parallel to time axis. Here we have a body starting from rest and moving with uniform positive acceleration. Why acceleration? Acceleration is nothing but change in velocity by time. So it is uniform positive acceleration. So next, what if there is decrease or increase in this acceleration? That is explained in case 3. So for a body starting with initial velocity, the body is started to move from origin with some velocity. It is initial velocity and moving with uniform positive acceleration. So uniform means straight line. From here you can see the straight line has been given. So why not from here? Because the body is starting with initial velocity. They are telling case 3 that body is initially at origin, it is at rest. It started to travel with a uniform velocity along the y-axis to some point A. From point A, it is displaced. It is displaced till this point. From the origin, it started with initial velocity and at one particular point, the object is displaced. Displaced is nothing but it is initial velocity and moving with, since it is straight line, it is uniform. It is showing uniform positive acceleration. So velocity is nothing but displacement by time. So it is displaced to some point, say B. It reached till A. So it is displaced till B. So it was moving with some initial velocity and again it is from here it is moving with uniform positive acceleration. Next you have case 4. What does this case 4 tell us? For a body moving with uniform negative acceleration. For a body moving with uniform negative acceleration. What is this? Positive is a straight line which is going, it is positive is a straight line like this. When you talk about negative, you have just opposite of positive, you get a line towards downward, which indicate a downward arrow. In case it's positive, it is a straight line. For a body moving with uniform negative acceleration. So this is a body which is moving with uniform negative acceleration. So you have time along x-axis, you have velocity along y-axis. Now the body is moving with uniform. Uniform means it's same. So you don't have any curve or any curve in the graphical representation. Since it is uniform negative, when we say negative, it is coming downward. You can see a downward arrow here. So body is moving with uniform negative acceleration. When it is positive, it is moving with some initial velocity, and when it is positive, it is moving upward. This is positive. When it is downward, it is representing negative acceleration. Next you have case 5. What is case 5? Case 5 is for a body moving with increasing acceleration. So far we studied uniform positive acceleration, uniform negative acceleration. Now apart from uniform, taking the sameness, constantness, removing the constant, we have increasing and decreasing condition now. A body is moving with increasing, it is increasing acceleration. That is change in velocity by time. So your velocity is increasing as time increases. So this is your increasing acceleration. Instead of straight line, you have a curve because it is increasing. Velocity is increasing as well as time is increasing in the x-axis. You get a curve. In case of negative, decreasing, in case of decreasing acceleration, that is case 6. What is K6? For a body moving with decreasing. It is the name itself tell that it is decreasing acceleration. As time increases, you can see the velocity decreases, the decreasing acceleration. Acceleration is change in velocity by time. Velocity is displacement per unit time. So you should be careful with these three terminologies. You should know what is acceleration. And here we have velocity along y and time along x-axis. As the body is moving with a decreasing acceleration. So instead of the curve for increasing is represented like this, for decreasing we can see it is just the reverse of increasing acceleration gives you decreasing acceleration. So velocity is decreasing with respect to time. So next you have case 7. So when a body is thrown vertically upwards, moves under gravity, What does this mean? We know Newton's famous universal law of gravitation. Apple fell down from the tree. That is due to gravitation. That is explained clearly by law of gravitation. We have the gravitational force. So when you throw the ball vertically upward, there will be gravitational pull. So object, or when the body is thrown vertically upward, it moves under gravity. So velocity time is along x-axis. You can see when the object is thrown up, it moves under gravity. Due to gravitational effect, gravitational force, you can see object moves under gravity. You can see a line crossing x-axis below x-axis. So this represents the vertically upwards. Object is thrown vertically upwards and it moves under gravity. So this is a graphical representation for case 7. So next, this is an important note. What is the purpose, significance of studying position time graph, its cases, and velocity time graph and its cases? So the note is very important. So you have to remember these note for the upcoming session. So the note says that the slope of xt graph, position time graph, at any instant of time gives us velocity of body at that instant of time. So this is the significance of xt graph. Next we have the slope of vt graph, velocity time graph. The slope of velocity time graph at any instant of time gives you acceleration of body at that instant of time, because change in velocity is your acceleration and change in position is your displacement, and displacement by time is nothing but your velocity. So xt graph gives you velocity, vt graph gives you your acceleration. So this is again an important point. The area under the curve gives the displacement of the body during time interval. So area under the curve. So you have a straight line. So you have a straight line. The area under this curve up to here, the area under this curve gives the displacement of the body during the given time interval. So this is an important note that you have to remember. What is the purpose and what is the significance that you study xt and vt graph. So in this session you have studied the graphical representation of motion. So first we studied position time graph. Under that we came across 4 cases, and next we studied velocity time graph. Under that we studied 7 cases. So you should remember what are the 4 and 7 cases. So the 7 cases had told us what happens to the object if it is at rest, and what happens to object if it is moving with uniform velocity, and what happens to the object if it is moving with initial velocity and it has a positive acceleration. And next we studied object is moving with positive acceleration, uniform. The term is very important. The graph represents straight line because of the term uniform positive acceleration. Then we studied what happens to object if you have uniform negative acceleration. Then we studied what happens to object if there is increase in acceleration as well as decrease in acceleration. Then we studied object is thrown up vertically, then it moves under gravity. How does that graph represented? So these many topics we covered in today's session. So this is all about today's sessions. So next I'll come up with more interesting sessions on motion in a straight line. So until then, take care, have a good day. Thank you.